5.
Number 5? Sounds good. Alright, and so do pay attention to how it's put together. These ones are not difficult, but there's that extra layer to them. Let me stretch my canvas before I get going, just so I know I have plenty of room.
Wait, so this assignment is 15.2, but there's also an assignment called 16.1?
Yeah, 16.1 is for next week.
Oh, it's listed. Okay.
Yeah.
But that's not homework. 16.1 isn't homework.
Nope. So the way that I organize this is it's kind of for you, but honestly it's mostly for me. The week 15, the first assignment of the week is 15.1, and all the stuff there is 15.1. Just tells me it's the first class we met with in week 15. And then everything for the 2s, 15.2, is the second lesson of the week. And if you're looking at the assignments tab, you do see I do have 16 published, because I was working on some of those things yesterday. But I thought I set this so that, yeah, the module's locked, so I guess you could get into the assignment. How are you getting into the assignment? Where are you seeing it? Is it in your calendar, or?
It's on my to-do list. It's listed as due today, so.
Ah. No, that's definitely not due today. Oh, but it does say December 16th. Thank you for noticing that. That was not supposed to be today. That's due next week. Alright, so hopefully that doesn't... thank you for bringing that to my attention super fast, because you're not the only student who would have that issue. Okay, so what I see here is, you see where it says I fired at an angle of LATEX. They're using a math coding language that I use on Canvas, and I'm going to have to replace that. Where did it go? Apologies for the technical difficulties on my end. Let me move this on the other screen so I don't have to deal with that every time. Okay, I just want to make sure I get this written the way it is in the problem. And it looks like it just was the degrees that it didn't like me using that copy and paste feature. Okay, so we're going to set up these problems just like we did yesterday. And I'll show you the one little spot where it's going to be different. Oh, I hate it. I'm going to have to resize this every time. Keeps trying to go to the center of my canvas. Okay, after all that, we're ready to go. Sergio, you just got here. Will you please read the problem on the screen?
Just to be sure, can you hear me?
Yes.
All right. A bullet is fired at an angle of 60 with an initial velocity of 200 meters per second. How long is the bullet in the air? What is the maximum height reached by the bullet?
All right, so we got two things going on. Two things we're going to look for But we still start the problem the exact same way. What's the first thing we got to do?
Draw a diagram.
Draw a diagram. So, in our diagram, for the first time ever, we have an angle. We're told how the bullet is fired. We know we have an angle of 60 degrees. And we know that we have an initial velocity of 200 meters per second. So in other words, we know the muzzle velocity of our gun. And it doesn't matter what angle I shoot the gun at, all bullets will come out of that gun at 200 meters per second. Does that make sense? And just like with last time, these equations will be super important to what we're doing. So I do recommend having them written down before you even get really into the diagram. And I'm going to add to this 2 more equations that we didn't play with so much yesterday, but we're going to play with just a little bit today. And they're the other 2 equations that I gave you last week that have to do with final velocity. So it's a lot of stuff that's got to show up on our picture, which, one more time, just like I said last class, this is why I taught you the 5 habits. These problems without those 5 habits get complicated. Yesterday I had a student that said, I didn't solve the problem your way, I just... And then we had a discussion about if you made up your own path, you're going to be wrong. There's no making up your own path on this. The way that I'm going to go through with you is the easy way. I remember, I don't know, like, I always hate quoting Albert Einstein because it turns out almost every quote we attribute to him, he never said. But there's one that's attributed to him that might really be one that's similar to something he said. I'd have to look it up, though. But it's a quote that says, always make things as simple as possible, but not any simpler. So once you try to go too simple, you're actually going to make mistakes as you go. All right, Kate, do you have these written down? Okay. I get a little hesitant because I know you got the 2 screens over there, but you look at one when I talk to you and you look at the other when you're doing everything else in class. So
it's just easier because then I can have your stuff on one screen and then my notes on the other. So.
Perfect. Yeah, I get that. Okay, perfect. All right. So, we've got a lot of stuff to put on our picture this time. In fact, let's just go through and look at that. We're going to have to put in the final position in the x, the initial position in the x, the initial x velocity, the x acceleration. We've got time, yf, yi, viy, ay, vf, y, and vfx. And the other stuff that I didn't underline, it's just because that stuff I already underlined at least once. So there's a plenty going on here. But if you have the equations, it'll help you through the process. So, I'm going to draw this picture again here. Because I know that this is going to have a path that's going to look like this. Having the 2 pictures, I think, is actually going to be helpful here. And how many of you, all of you actually, I've had you practice this before. I want you to annotate on my screen what goes where. So I want you to pick a variable, and I want you to draw with your mouse on my screen where that thing goes. And if you're confident you know what it is, go ahead and put equals blah blah blah. But if you don't, just put where that thing should be put. And there are certain things like your accelerations and your times, I don't put them in a specific place, I just put them somewhere on the picture. On your mark, get set, go. I can wait it out as long as you can. There we go, Zach S. You get bonus points today because you're the first one that did what I asked. And it's really, you can take an easy one because you can put it anywhere on the picture. Alright, Philip, what are you going to put down? Zach E, what are you putting down? There goes Zach. Gabe, Cade, Melisha, Gage, Sergio, and Tanner. Pick a letter, any letter. There goes Gabe.
How do you do the marker again?
So if you go to, it should be on the bottom of your screen, I think, but I'm not sure. There's some place where you're going to see, actually no, it's on the top of your screen. You're going to see something like you're viewing Sarah Whitbeck's screen, or whatever I have my name on here is. And then there's going to be a place where it says, I think it says options, if I remember correctly. If you click on that, there's going to be a place where it says annotate. And when you hit the annotate, you can draw, you can do text, you can leave stamps. Stamps I'm not looking for so much right here. I would put it on the screen to show you, but Zoom has this feature where if you put the Zoom stuff, like the video boxes, my toolbar, if I put any of that on the screen, it doesn't show up for you. There we go. This is looking good now. And I'm going to trace over what you have because if I scroll my screen in any way, your stuff just stays in the same location. And I will be scrolling my screen in a little bit. So I'm going to have your Y initial somewhere down here. Time can go anywhere. Your VIX, I'm actually going to move that just right here, because we're going to talk about how there's this X component to the velocity, and that's going to be one of the new parts. This Y here, I'm going to assume this means YF, Y final. We also have an X final at that location, and anywhere on the picture, acceleration in the X direction, your final velocity in the Y direction. Let's see, I've got 1, 2, 3, 4, 5, 6, 7 of those. But I've got 9 of you. Somebody hasn't gone yet. Granted, is this orange squiggle. I don't know if that was supposed to be something. Alright, Philip, have you annotated?
No, not yet.
Okay. Go ahead and put something on the screen. Yeah, so if you go to your features, or do you see at the top of the screen where it says something about you see my screen? And do you have an option for options?
Yeah. Oh, I'm looking in the wrong area. I found it.
Yep. I had said at the bottom, but it's up at the top. Alright, Tanner, did you go? You did? Sergio, did you go? Gage, did you go? Alright, do you know where the annotate feature is? Alright, so you see where it says that you're viewing my screen? You see my name on that? Okay, you figured it out.
So what would you like me to do?
Well, all those letters in red inside that red box,
Okay.
every one of those letters that I've underlined needs to show up on my picture in a semi-appropriate place. So you need to pick one that's not listed yet, and then I'll finish it off with the ones that you guys haven't gotten to yet. So far we have VIX, YI, T, YF, AX, VFY, and XF. Pick a letter that's not on the screen yet, and go ahead and put it on the screen. And Philip, which one are you doing?
I'm trying to find one that's not on the screen. Is the VIY on the screen yet, or am I just missing it?
VIY is not on the screen yet.
Sweet. Put this over here.
Is AY on there?
AY is not on the screen either yet.
Okay.
Alright. And, Philip, with yours, I'm going to put it over here as well. Because it's going to go over here with the initial stuff. But that's one of the new ones that we haven't actually talked about yet. Today's the first day I'm spending time with that. And then my AY can go just anywhere. Alright, so I'm going to erase what you guys have so that I can scroll my screen. And let's see. We don't yet have represented your initial X. And there was one more, I believe. I think it was your VFX. And then if I'm missing something else, I'm sure we'll figure it out as we go. Okay, so of these things, you actually don't know any of them quite yet. Well, actually, no, I take that back. There are ones we've gone over, but these things that they tell us in the problem, none of them are a letter that's represented on the screen. But they can help us find some things. So, for example, let's make this a little bit bigger so we can play with it. Remember in the videos I showed you, we talked about how when you shoot something at an angle, you break it down into its X and Y components. Does that sound familiar to you? You guys are getting, like, pulling teeth to get answers out of you the last couple days. Wake up! You awake? Did you sleep last night? Got one yes, one no, and then a bunch of blank stares. There's another no. Now, guys, I am 8.5 months pregnant. I sleep for 2 hours, wake up and stare at the ceiling for 2 hours, fall asleep for another, 30 minutes. If I can do this, you can do this, okay? Show me some life. You're young. You have energy. Somewhere in you, there is energy possessed in your body. I know you guys have your own, I'm not going to pretend like you're young, so therefore you should be able to sleep. Goodness knows there's plenty going on. Goodness knows you have plenty of other classes with homework. You have social lives. Technology has changed everything. And if you're spending time in the evening with technology, that does interfere with your sleep in a big way. But look alive! Okay. Alright. Have you ever in your life had to solve for unknowns that looked like this?
Yes.
How'd you do it?
I used SOHCAHTOA.
Perfect. This is the first time of the year we have had to use our good friend SOHCAHTOA. And it will show up again next week as well. We'll have a couple times this class where we use SOHCAHTOA, but this is one of the bigger differences between my class and Hendrick's class, is the problems that they do are more likely going to look like what we're doing right now, where I'm only going to do like 5 problems in the year that look like this, where his are pretty regular, where they have to remember all of this math together. All right, so SOHCAHTOA. What does SOHCAHTOA stand for? What's the SO?
Opposite over hypotenuse.
Your sine of your angle is your opposite side over your hypotenuse. Somebody that's not gauge. What does the CA stand for?
Cosine equals adjacent over hypotenuse.
And what does the TOA stand for? Somebody that's not Gabe or gauge.
Tangent, which is opposite over adjacent.
There we go. All right, so what is my opposite, what is my hypotenuse, and what is my adjacent in this scenario?
Your opposite is y,
Yep.
and your x.
Uh-huh.
Your hypotenuse is 200. Your hypotenuse is 200, your adjacent is x, and your y is opposite.
All right, it was just that last one I couldn't quite catch. All right, so we have the tools to find our x and y right here. If I set up one at a time, now tangent won't do us a whole lot of good here because the two things it needs are both unknowns. It's just not going to help us. But what I like on the sine and the cosine is there's only one unknown on each. One unknown, one equation, I can solve that. So, if I take the sine of my angle, I know that it will equal my opposite, which, let's at this point in time now finish calling it what it is, over my hypotenuse, which was just the plain VI, but I'm going to go ahead and put the number in. Voila! I have a math problem I can solve. I want to get rid of the 200. The legal way to do that is to multiply. And then the hardest part about this problem from this point on is to make sure your calculator's in degrees. I want you to go ahead and find for me what VIY and VIX each are. And I don't believe any answer till I hear it at least 3 times. And when you've got the answers, just shout them out. By the way, Zachy, rather. You turned in a homework sometime in this last week. I was catching up on my grading last night. and one of them you turned in. It was the wrong assignment. You turned it in under the wrong thing. So there's one. Check your grades. If you have one that you're like, I know I turned that in, but you gave me a 0. It's because you turned in the wrong thing.
Which one was it?
I couldn't tell you right now.
Okay.
But that I did catch that yesterday.
All right. That's good to know. Thank you.
Yeah. So double check that. I left you a note on it, but I know those notes don't always, like, Canvas doesn't always make a big deal of flashing those in front of your face.
No, I don't get notifications of those.
Yeah, okay. So yeah, look through the stuff you turned in last week. Click on them. There's one where I left you a note and I just said this is the wrong assignment. That's why I gave you 0. So, I mean, like, you did a great job on that assignment. It just wasn't the one I was asking for. All right, go ahead and annotate on the screen if you got an answer, and we'll see how many people get the same answer. Or shout it out, because again, I'm just whatever you get. It's a good time to check to see if we're all in degrees or not.
I'm pretty sure I'm not in degrees because
Uh-huh.
I'm pretty sure I'm not in degrees because I got 12,000. So
For which one? Just so I can put it down.
DIY.
DIY? Yeah, that sounds, 12,000. So I can see here, with my hypotenuse, it should be the longest side. So it does make sense that this side should be shorter. So that is a good check. Here's how here's how I, anyway, check to see which unit I'm in. If you're in degrees, if you take the sine of a 90-degree angle, you should get 1. But if you're in radians, when you take the sine of 90, you get something, I think it's like 0.87, blah, 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 blah. So if you're not sure what you're in, it's a really quick and handy check to take the sine of a 90 and see what you get.
Yeah, I got the 0.81.
Yeah, okay, so what calculator do you have?
I'm not using it. I'm just using my phone.
Okay, what phone do you have? Is it Android or Apple?
Apple.
Oh, of course it would be. Okay. Put it in front of the screen. Let me see it on your camera. I can't tell what any of that says. Oh, wait, no, I can. Down in the bottom, I see a DEG. Do you see in the bottom corner? I think it says DEG.
Okay.
Click on that.
Oh,
And does it change to RAD?
yeah.
Do the sine of 90 again just to make sure that we did put it in degrees.
Yeah, it's at 1.
Okay.
Oh, that's how.
All right, Bueller. Anybody have an answer? 200 times the sine of 60. Shouldn't take this long.
I got like 173 point something. I did it a while ago, so I'll retype it in. But...
Yeah, I got the same thing.
You got it, and then you weren't going to tell us?
Well, no, you asked for a different one, and I...
Oh, no, I said to give me both of them.
Yeah, when I heard like 1,200 or 12,000, I was like, I did not get that, so I'm gonna be quiet.
Yeah.
I got 173 as well.
I got 173.
All right, I feel confident when I hear 4 people get the same thing. Guys, don't like, be brave. Somebody says they get 12,000, be like, hey, I'll fight you on that. I got 173. You had people to back you up. All right, what about for VIX? Anybody get that? I didn't set that one up for you, but I am confident you can do the math, the algebra, to find VIX and put that in the calculator.
I got 100.
Okay.
I got 0.0025.
Okay. And this is where I like let's roll right out and down all the answers, see what we get the most of. I've got 9 of you. Could get 9 different answers. If we do, that's when I'll step in and I'll check the math. And since you're on computers, I know at minimum all of you have Desmos. And the more time we take on this problem, the less time you have with your groups. Philip, what'd you get?
I'm still working on it.
Zachy, what'd you get?
Also still working on it.
I'll come back to both of you. Zach S., what'd you get?
I got a negative number.
All right, what was your negative number?
Negative 190.5.
Perfect, okay. Cade, what'd you get?
I just don't know how to get VIX, so...
So, right here. If you have x over 200 equals cosine of 60, that's what you're solving for. I'll come back to you. Nilisha, what'd you get?
I was on the same boat as Kaden, so you just explained it. Thank you.
Okay, I'll come back to you. Sergio, what'd you get?
I'm not working on it, so. Well, I'm now working. not.
Okay. Tanner, what'd you get?
I'm still working on it, trying to figure out how my calculator works.
All right. Well, let's do the algebra together, apparently. So, but do know you're going to be on your own here pretty soon, because like I said, I'm only doing this one problem for you. If you want to solve for something on the top of a fraction, you got to solve it like an ogre. You want that 200 to go away. There's only one way to do it. And then at this point, you just got to put it in the calculator. Now, and again, anytime you use trig, because your units do show up in a calculator for trig, for angles, it's the only time the units show up in the calculator, then it is easy to get a bunch of these different mistakes. Like, I honestly, while I don't know how we got a couple of these answers, I've got a really, really good guess. In fact, I'm going to test out my theory on my other screen so I can show you what has happened.
I got negative 190.5.
Alright, so that's 2 answers there. And then I've now got 2 answers here, because I got one in the chat.
I got 100.
3 answers here. So it's almost a tie so far.
I got 100 as well.
Alright, so far 100 is pulling ahead. Yep, I was right in how you got those answers. And I will go ahead and share with you that is the correct one. Okay, so let me show you though, because when you're using trig, that you do have to be careful. And it's not helpful, I know that in your physics class we use degrees, but in your math class we use radians a lot. So I do this on Desmos just because I like Desmos best. And I want you to see up here, if you go to the toolbar on Desmos and scroll to the bottom, you can switch between radians and degrees. Whichever one's highlighted in green, that's the one that you're in. So I'm in radians right now. And so if you got the negative number, it was using 200 times 60 radians instead of degrees right there. And so that's where, if you do this trick, I bet if you put inside a 90, you would get that 0.87 blah, 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 blah. If you need help switching your calculator to degrees, because we're only using degrees in this class, radians is only a math topic, then let me know what calculator you have. There's a couple things. If you have a TI, usually you want to go to mode. If you have a DRG button, you want to make sure it's on the D is highlighted. Another one, it could just show degrees on your calculator. They all work a little differently. So if you got this answer at the bottom, means you're in radians. If you're using Desmos like me, it will default to radians. If you want degrees, you have to change it manually because it will always go to radians first. Which, for this answer right here, that one was in degrees. I'm going to come here and change this to degrees. On that one, what happened was took cosine of 60 divided by 200 instead of cosine of 60 times 200. Does that make sense? So that one was algebra. This one was units. Okay. So we now have our two answers, 173 for the y, 100 for the x. (173 meters per second here, 100 meters per second here, which means we also have them here. Oops, not just the unit. Need the number too. 100 meters per second. All right, now there's a couple of these other things that, while it wasn't given to you in the problem, you can very reasonably assume them to be true. I want you to look through all of these other letters that are on the screen. And while you don't know all of them, certainly, you should know 1, 2, 3, 4, 5 without having to look them up anywhere.
Well, AX is 0.
AX is 0 always.
And then we know VI and VY, but... Or
Yep.
VIY and VIX.
Yep, I've already got those. So I've got 5 more things, is what I mean. So there's 4 more things that you should know.
Oh, XI and YI?
So your XI and YI, yeah, what would those be?
0, I don't know, 0?
Because doesn't it make sense that your height here is 0? And that's your starting position. That's like your starting block for a race. Both of these would have to be 0.
T? Is that one of them?
Do you know T?
I don't know how it would.
I don't need to know either, especially since that's one of the things you're looking for. So, since it's one of the things you're looking for, I'm going to put a box around it. I'll give you hints. You should know this one. You should know this one. And there's one more you should know, but I'm not going to worry about that right now. You definitely should know these 2 things, though, that I just put arrows on. AY, always the same number. Every problem we do. Just sometimes...
-9. No.
Yeah, keep going.
9.8, negative 9.8.
It's going to be negative 9.8. And while we haven't used this concept yet, do you have a reasonable guesstimate for what the height will be when the bullet hits the ground?
0.
Mm-hmm. So while that's not necessarily something given, I think from the picture it's something you can very reasonably guesstimate. Now there is one more thing you do actually know, but it's something we've talked about but you haven't used yet. And that's the fact that your x component of velocity doesn't change. So these two things have to be the same in all the problems you do. Remember I showed you on the video, when you watch the components change as something flew through the air, the y component got shorter or longer depending on if you're going up or down, but that x component stayed the same length the whole time. Alright, and it looks like I don't know these things yet, and I notice it's asking for the maximum height, which is not something I labeled on my picture, so I'm going to come back here, and I'm going to call this y max. I don't know that either, and I'm going to put a box around it because it's one of the things I'm solving for. Now right now the picture honestly does feel chaotic, because I had you write on the screen, I had you put things down, and they just kind of went everywhere. For yourselves, personally, you don't have to do this, but I recommend instead of having this stuff just everywhere, I would maybe make a list and make it more organized for yourself. Does that make sense? Just because it is going to be chaotic then to find the information where you need it.
Are we going to go into asynchronous time today?
100%, yep. We're going to take probably the whole class time, especially since probably a good 5 to 10 minutes of this class period has been saying, what's the answer, guys? Where are we at? Give me something. Anytime that happens, and some of you that have had me in class before know, I'm not above holding you past the bell. Like in class, when we're in person. If I have to spend the whole class period, or too much of it, trying to pull an answer out of you, I'm not above saying, alright, I'm going to hold you after. So keep that in mind for when we do go back. Anyway, ... I'm not going to redo the whole thing. There is one thing I'm going to add to this picture, though. I'm going to add, and I'm going to explain why, this velocity max in the y direction. And I need to go back to my videos that we've seen. It's been like 2-3 weeks since we watched them, I realize. But, do you remember on the videos, as your object followed its path, like I said, that x direction component stayed the same length, but your y direction component kept getting shorter and shorter? Do you remember that? As it went up its path? Anybody? Do you remember what the y component was at the top of the path?
It's not 173, right?
Nope, that was just initially. That was just right here. It was 173.
Okay.
But then it got shorter and shorter and shorter. And then on the other side, on the path, that x component stayed the same, but the y component got bigger and bigger and bigger, you remember? What was the y component? Right there.
0?
There we go. It actually, the y component went away. This v max in the y direction only is 0, and that's going to be key for us solving one of the problems. You only need to worry about that when you're finding something about how high something went. Okay. So, we got plenty going on here. But let's go ahead and move on to habit 5, because I think we're ready to start putting stuff together. Let me erase some of what I have down here. So I can use the space. And let's put together our equations with the numbers in them, and then from the equations just try to make a path for how to solve what we've got. So again, it's kind of chaotic on this picture, but we have xf equals, let's go through and cross out our zeros actually. This thing was 0, this thing was 0, this was 0, this was 0, this was 0. Okay, just so I can not worry about writing those in the picture. Alright, VIX was that 100, T I didn't know, and then I had 0 equals 173 times T plus 1/2 times negative 9.8 T squared. I had my final velocity in the Y equaled 173 plus a negative 9.8 T. I have VFX equaled VIX, which equaled 100. And then I'm going to go ahead and do the velocity equation again, but for the max at the Y. That equaled 0, which was the same thing as, let's see, that VIY was the 173 plus negative 9.8. Now this time, I actually do need to be careful here, because this time here is the time to the max point, where this time is going to be time total to fall. So I'm going to call this one T max, which is going to be different than T. T max is not the same thing as T total. Plenty going on here. No doubt about it.
Wait. So the whole V max Y is equal to T max? Or is T max just the negative 9.8 times T?
So your VY max is 0, but then it also equals this equation, because it's going to be the same equation as this one. Because your final point... Yeah, your final point actually can just be whatever point you say, that's when I want to stop paying attention. It doesn't have to be when it hits the ground, when the motion stops.
Okay. So
it's our way of saying we're using this equation. So that's really good, because I didn't have this written out explicitly. This is going to be your initial velocity in the y direction plus your acceleration in the y direction. So it starts out exactly like everything else, but then it's going to be the time to the max point instead of the time total to fall, because I want to make sure if I'm looking at what's happening here, I don't want to use the time that it takes to fall to here. Okay, again, 5 habits. I taught you them for this point, but I also will point out, this lesson we're doing today is probably the most complicated of the year. You make it through this, everything else goes back to the way it was. But I want to acknowledge many of you will take a physics class after mine, a college university physics class. They're going to be filled with problems like this. So I don't feel like I'm doing my job if I'm not at least exposing you to them, so you can see kind of what goes into one of those type of problems. But again, since this isn't the honors class, I'm not spending the whole year on problems like this. We do enough to get a taste, but not enough that that becomes the emphasis of this class. And again, today is the most mathy part lesson probably of the entire year. Make it through today, it all goes back to normal after today. I will have some of these on the test though. Not many, like 1 or 2. But I'm going to have a little bit of this on the test. Alright, when I look at these, first of all, remember, the things with the boxes, that's what I'm trying to solve for. And what I see here is one of those things I can solve really easily because there's one equation with one unknown and it's got the unknown I need. The other one will take a little bit of work, but really, let's start with the one that's going to be easy to find. Let me erase what's down here again. And I am, by the way, I am recording this. I'm going to, as soon as class is over, I'm going to put it up on YouTube so you can go through this lesson as many times as you want to or need to. Oops. And like I said, too, there's just 4 more problems that you're going to be responsible for in your homework. And I think you picked a good one because of this whole max thing. There might be one other question where I asked you that. I'd have to look at it again. So I think you picked one of the harder problems for me to do, which I always think is a good idea. Now, here is something that, while this might not look like what you've done before, let's see, when you multiply these together, we get negative 4.9. So I'm going to rearrange this in a way that looks more math-like to you. There's more than one way to solve for t. There's 2 that jump out at me from your math classes. Remember, this is like solving for 0 equals ax squared plus bx plus c, but of course your c would be 0. What are some methods that we could use to solve for this? Think back to your math education. There are 4 technically that I would have taught you as a math teacher.
Oh, like factor and stuff?
Factoring? Oh,
Factoring. Factoring personally would be the one I would turn to here. But if factoring doesn't work, which it will on these problems, but if it didn't work, you could use something like the quadratic formula. Is that what you're about to say?
yeah.
Perfect. Those 2 would be my 2 go-tos. I try to factor first. If I can't factor, I go to quadratic formula. You also could complete the square. That is a valid method. And then there is a way to also solve it with graphing. But honestly, the graphing way, I can tell you, as also a math teacher, we haven't taught you much on that way. It's not a difficult method, but we haven't spent much time. This one, I think, is going to be the easiest on this problem. So, I look for what they have the same. Is there anything that these 2 terms inside my equation have that's common that I can factor out? Yeah, they do. Number-wise, no. But there is something that can factor out. Say it again, Kate. With your unmuted.
E?
There you go. I can factor a t out of both of them because they both have at least 1 t. And then remember, if you're set equal to 0, your goal then is you take each factor and you set it equal to 0. And you solve each of those equations. First one's easy because it's solved for us. Second one takes a little more work, but it's not difficult. And of course, since they're times, they're both in seconds. I'll wait a minute for you to catch up to me, and then I'm going to show you something really cool about what we just did. That whole process, what it got us, is it actually got us 2 important points on our graph. When your time is 0 seconds, that's the time that your height right here when your y is 0 meters, or your height, and notice I'm not putting an I or an F on that, just your height. And then the other one is your other time. If you were going to do a problem where you shoot something off a cliff, you'll get a negative time out of that. And it would just be, if you went backwards in time that far and shot it off the ground instead, you'd land in the same place as if you shot it off the cliff. When we call that time right there, time equals 0. Something that I'm definitely not going to stress for you this year, but mathematically is just a neat little relationship we have. Okay, we've answered one half of the problems. The other part won't take as long, because really the hardest part about this is always the setup. The math part is not going to be that bad. But the math part will be impossible if you don't have the setup together. Can I scroll my screen? Wave at me if I can scroll. Okay, I got 5 of you to wave at me. There we go. Yeah, I was going to say, Zach maybe was waving, but it was down here, so I couldn't see. Zach E. Zach S. I can't see anything but his hair now. There we go. You're shrinking. All right. Now, for this one about the maximum height. I wanted to throw these in just so I could talk about them. Let's just do the equation down here. I'm just going to call it TM for Tmax right now. Can you solve that equation for me? On your mark, get set, go. 173 minus 9.8 t. Treat the t like an x.
I got 17.7.
I got the same thing.
Okay, 2.
I also got that.
Perfect. Now, I want to show you something, and then we'll use it to find our final answer, because we are just about there. .7. What is the relationship, roughly? It's going to be different because of rounding. Between 17.7 and 35.3. And I will say, it's easier to see the relationship if you're comparing it to 35.4 with our rounding, though we do get just slightly different answers. But I think that's just because of where we rounded.
Um, 17.7 is like the middle.
Uh-huh.
It's like the highest point, I assume.
If you multiply this by 2, we get that 35.4. Now, granted, they're different because I think when you fed me that answer, or when I gave the answer, or whatever it was, that somewhere, the decimals were off because of some rounding somewhere. Whatever. But that time for the max point should be halfway between your 0 and your final height. So if you want to use that method, if I had given you another one where you have to find the maximum, you can just take whatever this time is, split it in 2, and you'll have that time. It's just another way to do the problem. You don't have to do it that way. I just want to give you multiple ways to solve the problem. Now, ultimately, sometimes we have to go back and remind ourselves, what was this problem asking me for in this last question?
Maximum height.
Height. Not time, not velocity, but height. Which means we do need to go back and use a height equation. And that's okay because, again, your final point, you can count that as just wherever you want to stop paying attention.
Wait, are all the problems under assignment 16.1 like this long?
Well, first of all, we're doing 15.2.
Or 15.2, yeah.
And second of all, no. No. There is one question that does ask you 3 questions in it, and this one asks you 2. Everything else, the other 3 ask you just one thing. Just find that one thing. And I also will, again, point out, part of the reason it's taking a long time, not even remotely the entire reason, part of the reason is I say something, I ask you a question, and I just get blank stares. That does always take a little longer.
But that assignment is our homework.
Yeah, finishing this assignment. So I'm doing one problem, the rest of the 4 are yours, and I want you to do it in study groups. And again, this is the most mathy lesson you're going to have all year long. So. But again, I want you to understand what that next level looks like. Alright, so anyway, your height, this YF max. This was 0. This one was, if I remember correctly, it was 173. This T is going to be the T max, so that's going to be the 17.7. And of course, this was negative 9.8. So, go ahead and find for me what that equals. And then we are done with that problem.
I got 1526.979.
Okay?
I got the same thing.
Twice?
Same here.
Alright. I feel pretty confident when I hear it at least 3 times.
I did it.
I got the same thing too.
So, and I think it's reasonable that we're not going to take our tape measure and measure it to the nearest thousandth place. I think it's reasonable to say 1527 meters high. So, if you shoot a gun at a 60-degree angle, This is saying it's going to go 1.5 kilometers into the air before it starts falling again. Can you think of professions where you might want to know that? I mean, kind of rhetorical question, but yeah, you can answer too. So, couple things on this. First of all, can I take the screen away? Okay. And again, I'm recording this so you can go back through it as many times as you like. Second of all, again, assignment 15.2. I'll go unpublish. In fact, let me just unpublish that one right now so it doesn't confuse you. That one, you did pick a good long problem, which again is a good thing. So we just did 5. You do have to make sure you turn in 5. I want to see that you copied it all down. This one asks how high did it travel, so this one is going to ask you for that Y max. So again, use VF max in the Y. I guess just V max in the Y. But it's going to equal the same equation. VI plus AY T max. Or you take half of the total. This is actually be the faster way since you don't have to find the other stuff. How far did the ball go when you hit the ground? You don't... No max needed. Calculate its horizontal range, initial vertical, initial angle of projection. No max needed. And how long will it take? So time to reach the ground. Again, no max needed. So problem number 4, you're going to have to use that max equation, but that's the only one. And again, we have the equations here, which I have a different answer there, but I'll go back and I'll double check that. And I'll get back to you on that. Okay. So, why did I put you through this? I mean, I've already said your college classes. If you take this again, I want you to just walk into it understanding that this is your average sort of problem in a college class. But second of all, how many of you plan to have a career?
Just a career in general, or
A career. How many of you plan to go to college for that career? You'd be surprised how many of the career paths do include the college physics class, or include a calculus class or a higher level math class. And it's kind of funny, some of them, because you don't really use it in the field, but they want to make sure that you know how to think in that way, because physics does train your brain to think in a very certain way. When I was getting my physics degree, one of our college professors sat us down and said, okay, you are going to be graduating with a degree in physics. What can you do with it? And the answer was basically everything and nothing. It was a good springboard to anything because it trained your brain how to think. And they need that in doctors, lawyers, businessmen, city planners. Like, they need people who have their brain trained in that certain way just to work through a problem. Anything that requires problem solving, a lot of times those require physics classes, even if the job itself isn't physics related. But when it came to the nothing, most places aren't going to pay you to do these problems. There's computer software for that at this point. So, one of the things I want to stress to you, especially with this being the most mathy lesson of the year, please, don't ever give up on your dream career because a math class or physics class gets in the way. I can't tell you how many people my age and older said, I wanted to be a doctor. I wanted to be a veterinarian. I wanted to be blah. But there was this one math class I had to take, and it was too intimidating, so I changed my whole career path and did something else because I was too afraid of that math class. And this is, of course, this is a glorified math class. So, when the going gets tough, it gets tough. You know what? That's fine. It gets tough. You have teachers who are here to help walk you through. if you will come to my office hours on Friday, I'll go through this entire assignment with you and you'll be done with it. Okay? We can do every single problem together. I'm okay with that. I also want you meeting with your study groups. I think you easily can do problems 1 through 3, especially without me. And if you get stuck on those, fine. I'll go through them with you. Because my goal is I want to make sure that you have the skills, not just to pass my test that's in 2 weeks, but I also want to make sure, Cade, wake up. I also want to make sure that you're getting a foundation underneath you for what comes next. So again, you're in general physics. I don't do these problems every day. In Hendrick's class, they do problems this level every day. That's the difference between our classes. Other than that, we teach the exact same stuff. So just know what that next level looks like. I just want to do just enough to expose you to it. But like I promised you, the lesson that we do next class will also be fairly math-based, but not quite like this. And after this test, which I'm going to keep this test short, nothing else, there's not a single other topic we're going to cover that's going to be this intense on the math. I just want to do just enough to get you to see it. Okay? If this is something you struggle with, don't get frustrated about, definitely don't drop the class, because everything after this is glorious. In fact, right after the test, we're going to be studying car safety features. Are any of you car people? A little bit, right there. Tanner? All right, we're going to be studying the safety features in cars, and it's going to be super conceptual. We're going to put some math into it, but nothing like what today is. And have any of you ever done an egg drop competition?
Yeah.
We're going to do that. Normally we would do it together, but can't do that this year. So just a heads up, you will have a lab of sorts in January, where you're going to have to pilfer one of your family's eggs. So check with your family to see if they're okay with you destroying an egg for the sake of science, but not until January. Okay, we'll get back into that stuff, but just want to do enough to expose you. It's late enough, I'm not going to send you into your breakout rooms, but you are, and I am going to, your discussion question, which I think I haven't published yet, your discussion question is going to be, tell me when you're meeting with your study group. That's it. And then meet with your study group and go through these problems. If you get stuck, let me know. Remember, I have office hours every Friday from 9 to 11 right here at this link. And like I said, I will do all 4 problems with you if you will just come to the office hours. If you can't do office hours for whatever reason, let me know ahead of time and I'll make special arrangements just with you. Okay? Any questions? Okay. Let's go ahead and stop recording.